Square numbers. Okay, so we're going to start off with the properties of a square. So two things that make up a square. First of all, the four sides of a square are all equal in length. So the length here is represented by L. And also the four angles, the four interior angles of the square are all 90 degrees. Now, if you want to know what the area of a square is, area equals base multiplied by perpendicular height. Now, in a square's case, the base is length L and the perpendicular height is also length L. So that will be length multiplied by length, or we can say the area equals the length squared. Okay, so now we're going to look at the square numbers. So the square numbers are 1, 4, 9, 16, 25, all the way up to any number squared. Let's just say x squared. Now, a square number is a number that can be represented as the area of a square. So if you look at 1, the number 1, it's 1 times 1 is 1 squared equals 1. If you look at 4, we have the square with side lengths 2. So that's 2 times 2 is 2 squared is 4. If we look at 9, we have a square with side lengths 3. 3 times 3 is 3 squared is 9. If we look at 16, we have a square with side lengths 4. 4 times 4 is 4 squared, which is 16. And if we look at 25, we have a square with side lengths 5. So 5 times 5 is 5 squared, which is 25. So they're the square numbers. Now, what if we have more than one square? So look at this example. I have 5 multiplied by 3 squared. So that's 5 squares that have side length 3. So 1, 2, 3, 4, 5. Or maybe another example, I have 6 multiplied by 2 squared. So that's 6 squares of side length 2. So there's 1, 2, 3, 4, 5, 6. So now an important thing to know when you've multiple squares is that we need to square first, then multiply. So what do I mean by that? Here I have an example that I have 7 squares of side length 2. So here's my squares, 1, 2, 3, 4, 5, 6, 7. Now if I want to know, well, what is the area of those 7 squares, I'm going to count the little squares. So let's count the squares. In my first square I have 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So my area is 28 square units. Now to make the 28, look what we had to do. We had to calculate the square first. So we had to see how many units were in the square. So 2 squared is 4 units. Okay, 1, 2, 3, 4. And then multiply that by the 7 for the 7 squares. So that equals 28. So that's important when you see something like this. You square first and then you multiply by the number in front. Okay. Okay, here's another example. If I have 3 multiplied by 10 squared, so that's 3 squares of side length 10. So here in my picture you can see I have 3 squares, okay, and they all have side length 10. So what I have to do is I have to figure out, well, what is 10 squared? How many squares are in this first square? So 10 multiplied by 10 is 10 squared, which is 100. And then I have to take that 100 and multiply it by 3 to see how many there are in 3 squares. So that will be 3 multiplied by 100 is 300. So can you see that? You square first, so 10 squared is 100, and then multiply by the 3 to make 300. Another way to look at this is the width of one of these squares is 10. So the width of the full rectangle of the full shape would be 10, 10, and 10 is 30. So that width there is 30, and the height of this shape is 10. So if you wanted to see how many squares were there, what was the area of the big rectangle, it would be base multiplied by perpendicular height, which is 30 by 10, which equals 300. Again, same answer. Okay, so when we think of the order of operations, you already know numbers 2 and 3, that you have to multiply and divide before you add and subtract. So now we have a new one, and this comes first of all, your squaring. Okay, so 5 squared, a number or a variable to the power of 2. So we will do our operations in this order. We will always square first, then multiply or divide, and then add or subtract. Okay? So let's look at this example. We have 3 multiplied by 2 squared, so that's 3 squares of side length 2. Add to that 4 multiplied by 3 squared, so that's 4 squares of side length 3. Okay, so here they are here. So there's my 3 squares, add to that my 4 squares. So the first thing we need to do is know how many squares are in each of my squares. What's the area of each of my squares? So we square first. So 2 squared is 4 and 3 squared is 9. Then I'm going to multiply my 4 by 3 because I have 3 of these squares, which is 12. And then I'm going to multiply my 9 by 4 because I have 4 of these squares, which is 36. And then I'm going to add all my squares together. So I have 12 squares on this side. I have 36 squares on this side. So then add the two of them together and I have 48. Okay, so my area is 48 units squared. So can you see what we've done there? First we squared, then we multiplied, and finally we added. Okay, so we squared our number, then multiplied it by the 4, and then added. So that's important to know. Okay, so what about squaring variables then? So what if I don't have the number, but I have a variable that represents a number? So let's look at some simplified expressions. What if I'd x multiplied by x? Well, that would just be x squared. If I'd y multiplied by y, that would just be y squared. D multiplied by d is just a square with side lengths d squared. Now, what if I'd a squared, which is a square, plus a squared, which is another squared? Well, then I have 2 squares, 2a squared. Let's look at this example. What if I'd an x squared plus an x squared plus an x squared? So I have a picture here for that. Here's my x squared. Okay, the side length is x. And I've got an x squared, add to that an x squared, add to that an x squared. So what do I have? I've got 3x squareds. What about this one? What if I have an or squared plus an or squared plus an or squared plus an or squared? I have it here in purple, look. Here's or squared, or squared, or squared, or squared. So how many? I have 4 of them. So add the 4 of them together and that means I have 4 or squareds. Okay? So what if I had 3b squareds and 2b squareds? How many squares would I have then? I'd have 5 of them. 5b squares. Okay, so what if I have 5 multiplied by x squared? Well, that's going to be 5x squareds. So look, 5 multiplied by x squared. So take your x squared and multiply it by 5. And what do I have left then? I've left 5x squareds. Okay. Now, interestingly, if you look at the top here, what is the width? It's x plus x plus x plus x plus x. So how many x's do you have there? 5 x's. And what's the height of this structure? It's x. So if you multiply 5x by x to get the area of this blue structure, it will be the same answer. It will be 5x squareds. So we can see there then that 5x multiplied by x equals 5x squared also. What about the example if I have 6 or squareds? Okay, so then 6 of them. So there's 1, 2, 3, 4, 5, 6. So there's 6 or squareds. So there's my answer, 6 or squared. Another way of looking at this is I have or plus or plus or on the top there. So I could call that 3 or. And I've or and or on the side there. I could call that 2 or. So 3 or for the width, and here is the height, 2 or. So 3 or multiplied by 2 or should be 6r squared also. So 3r times 2r equals 6r squared. Okay, so let's look at some substitution. Remember, substitution is just like playing a game of football. So number 1, find the value of 5x squared where x equals 3. So you know what we do, we take x out of the game and we substitute it with player number 3 and we put 3 in brackets. So that will be 5 times 3 squared. Now here then you need to remember that we need to square first before we multiply. So 3 squared is 9. And then you can multiply. So 5 9s are 45. Let's look at another one. Evaluate, which means find the value, of 8a squared where a equals 5. So a game of football, take player A off the field and put in player number 5 instead. Okay, and put player number 5 in brackets. So reading this, that's 8 times 5 squared, but remember you have to square first and then multiply. So 5 squared is 25, and then 8 multiplied by 25 is 200. Let's look at another one. Find the value of 2x squared plus 3y squared where x equals 4 and y equals 6. Okay, so player X is coming off the field and player number 4 is going in brackets. Player Y is coming off the field and player 6 is going in brackets. Now, do you remember what you do here? We have to square first, then multiply, then add. So let's square first. So 4 squared is 16 and 6 squared is 6 by 6 is 36. Now we're allowed multiply. 2 by 16 and 3 by 36. Okay, so that's 32 plus 108. And then finally we're allowed to add. So 32 and 108 is 140. Let's look at another example. Evaluate 7a squared plus 2b squared where a is 3 and b is 1. So player number A is coming off the field and player 3 is subbing in brackets instead. And player B is coming off the field and player number 1 is subbing on in brackets instead. Okay, so remember, we have to square first, then multiply, then add. So let's do our squaring first. So 3 squared is 9 and 1 squared is 1. Remember, 1 multiplied by 1 is 1. Now we can multiply, so 7 times 9 and 2 times 1. So that's 63 add 2. And now we can add, so 63 add 2 is 65.